Okay, so today's lesson, we're going to work on verifying trigonometric IDs or identities, and I break this up over 3 days so that it's not really overwhelming, and hopefully day by day, as I add a little complexity, you'll be able to transition pretty well. So today's topic is verifying trig identities when we're taking one term and making it into one other term. And we've done some like this already. However, now we have a little more skill. So let's take a look at your question. How do you use the trig identities to transform one trig expression into another? All right. And the way you do it might be different than me. There's multiple ways to get from one thing to another. It's kind of like if I were taking a trip to San Diego, and I'm here at point A at Gila Ridge, and I want to get to point B, San Diego. There are a number of ways for me to get there. There's a pretty direct route, but that's not the only route. Why? There's many roads that will take me from here to San Diego, and these problems are very similar to that, and that the path that you come up with, or your map from one side of the equation to the other, might be different than my map. Okay, but I did try to come up with some guidelines so that your map isn't too convoluted and you don't have to go down too many streets. I'm using a metaphor. Do you get it? All right, so before we start looking at these steps that I provided for you, let's just record all of the trig identities that we are going to have to use. And let's try to do it from memory instead of looking at your trig ID worksheet that we had last Tuesday. Let's start with the reciprocal identities. And I'm just going to squeeze them in to any white space I can find. So the reciprocal IDs. I'll start, you finish. Think reciprocals. Cosecant of theta equals 1 over sine theta. Or what if I say sine theta equals 1 over cosecant? Okay, so reciprocal identity number 1. Let's go with, if I say secant of theta, you say 1 over cosine theta. If I say cosine theta, you say 1 over secant. Okay, last one. Cotangent of theta equals 1 over tangent of theta, or if I say tangent of theta's reciprocal is 1 over cotangent. Okay, so those are your reciprocal identities. Let's also talk about your quotient identities. And your quotient identities, last week I was calling the fundamentals. And that's because the textbook calls them the fundamentals. But when I talked to Miss Ratcliffe, she says we call them in calc the quotient identities. So I'd like to change that terminology a little bit. So here are the two quotient identities that you should memorize. Tangent of theta equals, as a quotient in terms of sine and cosine, sine over theta over cosine of theta. And the other one is the cotangent in quotient identities, cosine over sine. And that's because they're reciprocals, correct? All right. So, and we would use those to help us decompose into sine and cosine so that our map of our problem isn't so crazy convoluted and hard to solve. Okay. The other 3 identities that I want to talk about are the Pythagorean identities. I'm going to squeeze them in over here. So the Pythagorean IDs, and let's see if you can remember them. I'll start, you finish. 1 equals sine squared theta plus cosine squared theta. Okay, really important one for sure. I'll start the next one. Secant squared theta equals tangent squared theta. Yep. This has got to be something you memorize and it's easy to access. Last one. Cosecant squared theta equals 1 plus cotangent squared theta. And so now just remember that I can say, okay, Using the Pythagorean identity, tell me what cosine squared theta equals. What's cosine squared theta equal? Yeah, 1 minus, you got it, 1 minus sine squared theta. But I could also say, okay, so what if I said, what does tangent squared theta equal? Okay, so just remember, you guys got it. Just remember that you can, the Pythagorean identities don't always come in this nice little, you have two things that you're adding and they equal one thing. Sometimes you're using subtraction instead. So you may have to write other forms of Pythagorean identities to find your map from one side of the equation to the other. Okay, and I do want to change one other thing in my notes that I forgot to type in. First, step 1 is an option. I like step 1. I like to look at the problem first to see if I can simplify it before I decompose it into sine and cosine. But you don't have to. You can go straight into decomposing every single time. But I like to simplify things as soon as I possibly can. So if I can see any Pythagorean identities, or if I can get rid of a fraction and write a reciprocal or something, I'll do that. So I'll look for any identities that might simplify the process. The other thing here is, so we'll do step 1 if you choose. Step 2, everybody does. Step 3, everybody does. And step 4, everybody does, but step 4 is missing something. Apply reciprocal, quotient, or Pythagorean identities. I don't know how I missed that. If necessary. Okay. So hopefully with all our prep over the last week, we should be able to do this pretty easily. So I'm going to do the left side problem, then you're going to do the right. So I'm going to start with reading the instructions. Verify each identity. So the left is identical to the right by transforming the left to the right. So I want to make sine of x, secant of x, say tangent of x. So to do that, first I look at it. I don't see any Pythagorean identities. Do you? I also don't see anything complex. It's just a straight multiplication equals a number. So first thing I'm going to do is decompose. So I don't need to decompose sine because it's already in terms of sine. So I'm going to write sine of x times, but I am going to decompose secant into terms of sine or cosine. So how do I convert secant into something else? So 1 over cosine x equals tangent of x. And over here off to the side, I'm just going to write myself a little note that I was decomposing, okay? Because on your test, you do have to write down what you did in each step to get full credit. Okay, second step, now that we've decomposed, can we close the door, please? That's crazy. All right, all the time. Okay, so truth. So now we're on step 3, simplify. We decomposed into sine and cosine. So now on the left-hand side, we're going to simplify just means add, subtract, multiply, or divide. That's what it means. So we're going to multiply these two things and replace this with sine of x over cosine of x, right? Because you're just multiplying. I can put a 1 under that sign if you need to see, if you need it so you can see it. You're just multiplying. Equals tangent of x. And in that step, all we did was we simplified. We multiplied. That was a simplification step. Okay, so that's step 3. Step 4. Can I apply a reciprocal, a quotient, or Pythagorean identity to make sine of x over cosine of x be tangent of x? A quotient identity, right? So I can replace sine of x over cosine of x with this quotient identity, right? Over cosine. I don't know what I just said right there, but sine over cosine equals tangent. So there we have it. Tangent of x equals tangent of x. And I used a quotient identity. So over here, I'm just going to write that I used a quotient ID. And you can abbreviate the words. You don't have to write the full word for me to understand that you got it. And there we have. We have transformed the left side into the right side. So you try one, press pause, try it out, then come back to the video and let's see if you got it. Okay, so we didn't see any Pythagorean identities or anything to simplify the problem, and so here's what I see. 1 over sine is decomposed from cosecant, tangent sine over cosecant. That's cosine. I don't know why I'm saying the wrong things. Equals secant. Then multiplying in our simplification, we can cross simplify. So that gives us 1 over cosine, which then turns into secant. All right, so let's move on to the next set of problems. Now these ones are a little different because this is a quotient instead of a product. The last two problems you were multiplying, and here you are dividing. Well, here's something you could think about. A couple ways we could do it. We could go straight into, should we change these into their Pythagorean identities? Do I want to replace cosecant squared x with 1 plus cotangent squared x? Do I want to complicate this, or am I just trying to take something that's fairly simple and make it even simpler? Right? So let's not go into Pythagorean identities. However, that could have been one of those like alternate routes from Yuma to San Diego. It just would have been a really long route. And you probably could have got lost. Just saying. So a couple things you can think about. So this is cosecant, and this is cotangent. And cotangent's in the denominator, right? So if I want to bring cotangent out of the denominator, what do I change it to? Could I change it to tangent? Yeah. Is cosecant times tangent the same as cosecant over cotangent? Let's look at that. I'm going to come over here before I decompose, because if I decompose, I'm going to create a complex fraction, which I can solve all day long, and I think you guys can too. But I would like you to think about it. Could I write this as cosecant squared x times 1 over cotangent squared x? Does that equal that? True statement? Right? And I can then convert cotangent into 1 over cotangent into tangent squared. So if I want to bring this cotangent out of the denominator, all I have to do is write its reciprocal, right? So I could rewrite this as cosecant squared x times tangent squared x. And that would be my, I'm looking at the problem, how do I avoid a complex fraction? So I don't know if you see that or not. I can write it as a complex fraction if you would prefer. But I think that's a really good way to tackle that. Equals secant squared x. You with me? And so that was more, I'm just applying some of my reciprocal identities. I'm doing this thing where I'm looking at the problem, any Pythagorean identities and or reciprocal or quotients. I use some reciprocal identities there. All right, so here we go. Now I decompose, right? So here I used a recip ID. That's what I did. I used a reciprocal cotangent to make it tangent. Right, 1 over cotangent is tangent. Now I'll decompose. So cosecant is 1 over sine squared x, and you have to keep the exponent. And tangent is sine squared x over cosine squared x, okay, equals secant squared x. So that's decomposing. Now, can we simplify? Can I cross simplify? Right, I would like to do that. So that's why I grab out my blue pen there. So that's 1 over cosecant squared x. I think we've done a problem very similar to this. Secant squared x. So that's our simplification. And then, last step, replace 1 over cosine with secant squared x. And if you guys catch me calling cosine cosecant again, please let me know. I don't know why that's happening, but that is a reciprocal ID. Okay? So do you want to see that in an alternate way, or does everybody understand why I replaced the cotangent in the denominator with a tangent in the numerator? Are you guys good with that? Okay, because it's a great strategy to avoid a complex fraction. Okay, you try the next one and then come back. Well, there you can see that we applied the same idea as this other problem here, where we, instead of having secant over cosecant or secant divided by cosecant, we decided to do secant times the reciprocal of cosecant sine. Okay, and then we decomposed into sine and cosine by changing secant into 1 over cosine. Then we simplified by multiplication, and then we use our quotient ID to change sine over cosine into tangent. Questions? All right. So now we're going to go to the ones that are a little more complicated to look at. So I told you that we were converting one term into another term, and although this is a really complex looking term, it is just a fraction. It's one fraction equals one product. So one quotient equals one product. That's what that says. So there's a number of ways we could go about this, but I like to look at it first. And I'm looking at this numerator going, hang on. I'm going to grab my red pen. That looks like a Pythagorean identity to me. So cosine, negative cosine squared x plus 1. I know that cosine goes in the Pythagorean identity that says 1 equals sine squared theta plus cosine squared theta. And so if I move the cosine over here with the 1, I'm going to subtract it, right? So that's pretty much saying 1 minus cosine squared theta. I don't think that this says anything different. They're just in reverse order. It says negative cosine squared theta positive 1. It's the same thing. So what can I replace it with? Sine squared theta. I can. So I could use my Pythagorean identity, and I would do that right there, just so that I don't have, it's a little bit simpler to work with. And then everything, I don't have to decompose because it's already all in sine. So first, let me rewrite. So we have 2 sine squared x. And here's the reason I didn't look at that as part of a Pythagorean, because we don't usually see a coefficient in a Pythagorean identity, unless it was 2 sine x plus 2 cosine x equals 2. Then maybe. Okay, so I'm going to replace negative cosine squared x plus 1 with positive sine squared x all over sine of x equals 3 sine x. And I used a Pythagorean ID. So a PID. That's all I need to see, okay, that you used a Pythagorean identity to simplify. All right, so that's step 1. Step 2 is decompose, but it's already decomposed. Everything's in sine. I don't need to change anything. So step 3 is to simplify. Can you see something in my numerator that I can do? Are they like terms? So I can add them. So 2 sine squared x plus 1 sine squared x is 3 sine squared x. All right, so here we have 3 sine squared x over 1 sine of x. All right. And so that equals, it's supposed to equal 3 sine x. Let's take a look. How do we get from here to here? Maybe we should use some expansion so that you can remember what sine squared x means. I'm going to do this one time. So I'm going to replace 3 sine squared x with 3 sine x, because that's what sine squared x means, over sine x, so that it's easier to see what you're about to do. What are we going to do? We're going to simplify. We're going to divide out their common factor, right? Equals 3 sine x, and there we have it. 3 sine x equals 3 sine x. And of course, you may have seen it here. So here you may have seen, okay, so here's 1 sine x, so I'm going to take that one out, so that there's, instead of a second power, there's only 1. And you might see it there instead of having to expand it out, but I think the expansion explains. So let me go back and put in my, look, I didn't follow my own rules where I was writing down my process as I go. So step 1, I used a Pythagorean identity. Step 2, I simplified by adding like terms. Step 3, I expanded. Yeah? And then step 4, I simplified again. And I didn't need to expand, but I did want you to see why. Okay? All right, now the next one, let me tell you something. You might be able to do it in 2 steps. We'll see. I'm going to press pause and see. So with this problem, I never decomposed it at all. Shh. I recognized that 1 plus cotangent squared x is a Pythagorean identity, which I could replace with cosecant squared x plus sine squared x. And then I looked at these. These are reciprocals. When you multiply reciprocals, you always get 1. And so you could have decomposed in the intermediate step here, and I think that's fine that you do that. But it's nice to see that in action when you're multiplying reciprocal functions that you get 1. So if I were to do this in the intermediate, I would decompose cosecant into 1 over sine squared x times sine squared x basically over 1. And there you can see that that's sine squared x over sine squared x, or you can see in action that when you multiply reciprocal functions, you always get 1. Okay, so your homework today is a portion of the 7.2e assignment on Canvas. Here are the problems I'm assigning today. Problems 3 and 7, and I would suggest hold those till last because they're a little bit more complex, and then do 13 through 17 first. They're a little bit more like your notes so that you can kind of develop your own way of going about it, build your confidence up. And then 3 and 7 are going to challenge you a little bit. You can do it, okay? And these assignments are on Canvas. And you have the rest of the period to work on it. Summaries included for stamps tomorrow.